Hi everyone, this is Tier 3. We're focusing on land use, walkability, transport, and sustainable land use. So recall from last time, at the beginning, we had the videos on new urbanism and designing for inclusion.
So I need you to go back to these two videos and watch them again because you need them for this part. It will help you so much.
Now we want to think about planning for walkability and accessibility, how we organize space, because there needs to be a place for people to walk for the benefits that were mentioned before. And there needs to be a place for nature to operate and function and improve the climate. So we want to think of organizing space as if you're the kind of person who goes into a room and knows how to organize, let's say, the furniture or things on the table, and you kind of feel the energy of things, that this feels more harmonious, or the feng shui of the place. Urban design, in this sense, it will make sense to you in terms of how you locate things. And this is something that's been practiced before historically, and we will look at how it's been done. Now, the problem that that was discussed in first videos about urban sprawl is that it started to grow and there was more pollution. But the other problem is the architects and the landscape designers, they really lack sometimes the knowledge of how nature works. They lack the knowledge of permaculture. So if we know permaculture and how permaculture is meant to enhance the land to be more productive and the biodiversity to thrive and the people to thrive in using renewable energy, and so therefore with zero waste, they will take into consideration the functions of these places. Now, how are we going to learn more and educate ourselves more? By looking at, for example, biomimicry. For example, asknature.org, it allows us, if we look up over there, it tells us the functions of nature. For example, how does it control flooding? How does it distribute resources? So you can find so many examples that you can mimic, but also not only mimicking examples, it will tell you the nature of these beings and organisms, so you can respect them and allow for them to survive. All right, now, we're going to be looking at urban villages and new urbanism. Both of them have the same ideas. New urbanism, we already discussed it, but we're going to review it again. And the history of some examples in history for urbanism. We're going to look at urban permaculture principles and how can we use biomimicry for design, and then mapping and visioning space activity. Now, I'm going to share with you many examples as we go. Now, in an urban village is an urban development typically characterized by medium density housing, mixed use zoning, good public transit, and an emphasis on pedestrianization and public space. Contemporary urban village ideas are closely related to new urbanism and smart growth ideas initiated in the United States. Urban villages are seen to provide an alternative to recent patterns of urban development in many cities, especially decentralization and urban sprawl. Generally, they lead to reducing car reliance and promote cycling, walking, and transit use. They provide high level of self-containment, people working, recreating, and living in the same area, help facilitate strong community institutions and interaction. So basically, this started in the 1980s. New urbanism supports community building, concept of neighborhood with no sprawl, and nostalgic, as in it has its own flavor with historical parts that are not being forgotten. Small, ecological, so there's a lot of green spaces, walkable, lively and safe. Mixed uses of land, heterogeneous populations, as in diversity as well. So here, diversity of people, diversity of land, develop public space. Now, landscape architects. Okay, so let's talk about these, because they might be a problem and they might be a solution at the same time. So that's why it's important for them to learn permaculture and ecological design. So a landscape architect is someone who creates beautiful outdoor spaces. The scale of the profession focuses on master planning, site planning, landscape design, project management, and implementation as well. Projects can range from very small to very expansive residential neighborhood parks and golf courses to regional recreation, environmental, transportation, educational, commercial, institutional, and industrial projects. The skill and talent of landscape architects is visible all around us when we see the beauty and usefulness of our parks, natural areas, gardens, urban plazas, streets, neighborhoods, and communities. Landscape architects design aesthetic layout of golf courses and shopping malls, as well as other public spaces. They can also be hired privately to design the landscaping of homes and gardens. Landscape architects can also choose to work in the environment field, designing conservation lands such as wetlands and participating in historic restoration endeavors. A landscape architect will work with their client to meet the vision that they have for their outdoor space. No matter how big or how small the project is, the landscape architect can turn a bland piece of land into something special. During these initial meetings with the client, the landscape architect should be able to get a clear idea of what the space will be used for, as well as how it should look like. The majority of clients will also have a budget in mind, and the architect should keep this in mind during the design process. Fine, this is great. However, we have to make sure that the landscape architect knows the type of the land, the properties of the land, the climate impact, and the accessibility, the walkability, and all of the sustainability aspects, meaning the impact on the ecology, the impact on the economy, and the impact on the people. If sustainability is not taken into consideration, or permaculture, meaning knowing the land, knowing the water, knowing the impact on the biodiversity is not being considered, here we have a problem. Okay, that's why we need to know as much as we can. Now, urban designers, they are tasked with shaping the city's future urban form. This needs to be a collective vision of the dynamic and inclusive built environment designed for all people. So what this is going to look like, for example, here in Portland, it was a dense, compact neighborhood with a healthy mixture of housing, jobs, and services. It's the opportunity to live car-free, if you want to, because there is a variety of different ways for you to get around. Its neighborhoods are organized and anchored around urban parks where we can embrace ecological urbanism to promote a healthy and active lifestyle. This is what we are looking for. In a city, as a living laboratory where we can embrace and experiment with new ideas and innovate so we can foster new job growth, emerging business sectors, and keep a competitive edge. So we want our cities to evolve, keep on evolving to survive. So in order for us to do this, we need to push the boundaries of how cities look and function and create a framework that structures intentional growth and change over time. So I'm quoting these things, by the way, for you, but basically we want cities that involve something called urban metabolism, meaning that the energy flow, renewable energy, the waste gets used again. We have spaces for ecology. So if you watch previous videos, there is more about urban metabolism. Now, in ecological design or eco-design, it's an approach to designing products or places for environmental impact. We also look at the product's whole life cycle. And so basically these help in green architecture, sustainable agriculture, ecological engineering. So basically ecological design is the process where design and development includes the environmental consideration and by reducing the environmental impact. Sustainable landscape management is very important for us to consider, and I will show you now an article about that. Okay, so this is an article entitled Sustainable Dryland Landscape Management. So this is basically for Jordan. And when we look at the content over here, we see that this mainly looks at the following. It looks at the vegetation map, the soil map, the elevation and topographic maps, land use, vegetation, and macro catchment water harvesting projects, and the socioeconomic data. Now, watersheds are very important, and so are soil maps and land and the vegetation and the land use. Why? Because these will tell us how we can divide the land for us and how we can use this land. Now, if the soil is fertile, then I need to use it I need to probably make more food over here and food forests. But if the land is not very fertile, maybe I can use this for built environment. I can make more buildings. So I can provide you with the document, and you can see all of the maps as a reference if you choose to work with the country of Jordan. So here basically they talk about the rainfall, etc. So it's very important for us in order to plan in an ecological way And in a permaculture way, we have to also consider the type of the land, again, as in the soil, the vegetation, the topography, the heights, the elevation, watersheds, and the rainfall, in order for us to inform the next steps. Why? Because this could be a problem if a land is fertile and we are not, and we are building on this land, then we are ruining the climate and we are ruining the biodiversity, and our climate is already suffering, so we need more land. Even if the land was not fertile, it is possible to make it fertile by adding compost, by adding mulch. In time, there's a project called Greening the Desert in the Dead Sea. They actually called it Greening the Desert just to challenge the idea, and it's basically a whole forest where they make food, and people actually make money out of it, and they make a living out of it. So we have to be very careful of the type of land, and we need to have a plan. We need to be very organized, and this chaotic building of everywhere and construction, this is what is ruining our climate, also our quality of life, as well as the increased number of cars on the street. And this is ruining also the air quality and our well-being. Possible to make changes, but we just have to give the right for land and the right for human beings. And usually it's 50% for human beings, 50% for nature. As you saw before, that urban sprawl causes a lot of socioeconomic problems and also environmental problems. So we can combat these problems by removing that urban sprawl and designing according to new urbanism criteria. Now, let's have a look at some historical maps. I have these references over here. I'm going to show you now this map in Erbil. This is the Arab neighborhood. Let me read the caption here for you. The Arab neighborhood is located in the center of Erbil, and their traditional houses are so old, it's believed that the neighborhood is about 200 years old. It was named after the 20 Arab families who lived there in the 1930s. This neighborhood was well known by the high social interaction among its residents, who used to share food and live peacefully in spite of their different nationalities and religions. So we're talking about socioeconomics. So basically we have fair share. Just like the traditional Islamic cities, the Arab neighborhood has winding streets. Its alleys are narrow and mostly with mixed use, residential and commercial. So there is also diversity in the use of the streets. So you can see little shops spread either within the same residential alley or within those little nodes in the interactions of those of two or more alleys. Each little or main node used to witness mixed kind of social interactions such as shopping, talking, chit-chatting, playing, etc. Look at this shape, and I want you to imagine once we start looking at biomimicry, you're going to see that many of the shapes in nature they have these shapes and form, meaning that back in the day, most of their work was actually mimicking a lot of the natural forms and shapes that they saw around them. So this is basically the urban map of Rome. And you can see here the built area. So look at the key now, how it's labeled. So before they had it all, they had the labels on the areas. They put the labels on the map. Whereas over here, now they used different color hues over here to tell us something about the map. So here in gray, we have the built area. The streets are in white. Villas are in pale green. Then we have the gardens in green. Then the teal, we have vineyards and orchids with another green hue. And then non-cultivated are left. So this kind of follows the rule of 50% human, 50% nature. And that was in 1748. Now here, this is a more detailed one with more fragments. So you can see how they have also color coded each region of the built area. They've included in the built area a lot of greens as well. So as we're looking at the city of Rome. So here you see colleges, seminars, and hospitals, palaces, towers. You know, feel free to pause and look at this, and I will provide you with the PowerPoint, squares and streets, villas. So it's mixed use, and we can tell they are high density. But if we look at the streets, they allow permeability, but There's not much sprawling happening at this point. And this is the physical structure of Rome in the 18th century. We can see how 50% of it is for nature, and the other 50% is for humans. And now, if you ask me and you tell me, okay, why this is a problem now, we have increasing populations. Yes, but there are ways in architecture to build efficiently and utilize the space. And a lot of that is also looked at in biomimicry. If you look at how nature efficiently utilizes space. So there are so many shapes that you can look at, and from there you can mimic your built environment. Now, topography is very important. You can see how there's different elevations, which is good for water flow, good also for building food forests and streams and peatlands, and for just nature to do its thing. Over here, it's showing how there's a loss also of urban heritage, because they started to do new road networks, and they started to isolate archaeological sites, and they started to have new urban expansions. So colors over here, the different color hues, they represent how much of the land was lost. The urban heritage means like for the history and the cultural aspect. This is a plan of Baghdad, 2017. Basically, it was a round city. So the concept was also round, just like Erbil. But that also disappeared after a while, after the different empires moved in. But in these years, basically, it used to follow these shapes. And a lot of the shapes in nature kind of look like that. We want to look for curves. As much as possible, look for curves in nature. I'm going to share with you some of my biomimicry shapes. And basically, we know that biomimicry, it's an approach that seeks sustainable solutions, an approach to innovation, to find sustainable solutions to human challenges by emulating nature's time-tested patterns and strategies. So this is from my course at the Pratt Institute for Biomimetic Design. So we emulate the form, the process, the ecosystem for a sustainable design. So we mimic the natural form, meaning the structure. Second, the natural process, how it's made, and without any toxins and having negative impact on the environment. Also, this also means the physics of it. The natural ecosystem, for example, the material and the impact also on the people and the air quality. So basically, the form for level 1, natural form, for form, geometry, patterns, and numbers. Level 2, natural process. Level 3, the natural ecosystem, how it contributes to the social responsibility, the performance, the indoor environmental quality, and life cycle analysis. We discussed this in tier 2, the life cycle analysis, if you want to see. Okay, so let's have a look at the natural form, level 1. So here's an example of some of the natural forms in nature that really work for urban design and planning cities. Okay, so I'll provide you with this. I want you to take a very good look at this and see how you can divide your space with these shapes. These are the starfish shapes, but for all of the criteria that we're looking for: increased walkability, ecological, and allow people to interact more. Here are more shapes to look at. Microorganisms, we're looking at freshwater microorganisms. They're amazing. And here, more microorganisms. Now, I use this for water, for streets, for designing streets, a shape I took for designing streets with food forests, for planting food between them, but also for urban drainage. These work really well. So these also work. You can have food forests in certain areas next to a river. If you have like a water body, next to it, you need to have a food forest. And you can have the residential area, but always have in this area a green area next to the blue area. Always have green next to blue, because it does the retention. It absorbs water and it prevents flooding. I'll show you how this looks like in more examples on the slides. Look at the golden ratio, the famous golden ratio. This is a very neat way of organizing space. This one provides elevation. Elevation means if you have topography with different levels, the land, for example, Jordan, We have different elevations. This is very good for water collection and sequestration. Water actually in Jordan can be easily collected because of that very difference, the difference in gradient and the height gradients from, from north all the way going down to the Dead Sea. The Fibonacci cactus, this also is an excellent way of distributing your land and streets. And your streets are meant to be collecting water. And that's called urban drainage. In this year, we talk about urban drainage as in collecting water. So if you want, you can look at that. But you want to collect water on the sides of the streets. So to allow that space with kind of like a bit of a tilting, and it can take these patterns and flow. And here's another way of distributing a neighborhood as well, another shape. So feel free to choose whichever shape you want and whichever geometry you like. Here's another Fibonacci sequence of this plant and butterfly. When it gets magnified, we see these patterns. If we look further, we see these patterns. They're excellent for catching water. These elevations, they provide, this is like contouring the land with swales. And what are swales? I'll show you now in a second. This is a food forest, and a food forest basically has 7 different types of plants that are edible. And so basically they can be sustaining a house or a neighborhood or even a city if we make them on a large scale. But the best thing about them is that they have a variety of types of plants. So this makes them very successful. So if the climate changes, they can survive, but also the microorganism, the mycelium connections in the roots, they help them survive better. So diversity makes their lives possible. Now for flood control, building swales, and swales mean we contour the land. When we contour the land, this allows the water to flow in. So it creates, for flat land, when the land is flat, over here, flat land, we make a contour on the edges. So we make it with an elevation. And that's why I showed you the previous shapes, that there's like a difference in the kind of like a curvature and a contouring, something like that. When the shape goes with an elevation, this allows also a height gradient, so the water flows in like that. That's what I'm trying to say over here. So you can create these different elevations in the land to allow water to flow in, to allow building of food forests, and catch water at the same time. So here, as you see, this is how we can contour the land. This is runoff for the water. This allows water to flow in, and it allows planting of the roots of the trees to hold the land at the same time. And this is also excellent for water runoff and controlling water and flooding. So whenever there's a river and it's expected, the amount of water is expected to increase around it, just increase the retention area by increasing the amount of land available next to it and remove any built area and build these swales and food forests next to them. And you can pick any of the shapes that we provided before. Also, if we give the chance for streams and peatlands to be available, what they do is they treat the water naturally. It's a way for treating water. And here, gray water treatment also can happen in our homes, also by following the peatland and streams way of doing it. So here, for example, in the city of Rotterdam, to prevent flooding, the colored in green area, we did that. We added swales with perennial plants that help hold the roots and prevent erosion, and they help infiltration and climate control. And then streams were connected also to the river to allow the water to flow in and also for filtration. We also can plant edge species in between. And we also have peatlands, which help also in fluctuating water levels that can be also connected. Peatlands need a time to grow. They need their time to be formed. Also for meeting the water needs, we added more reservoirs connected to streams, and we added this is a project that I did for a city of Rotterdam with my team. And then the road network followed the leaf structure over here. So to allow water to be collected on the sideways of streets. So we see that this is the river is also surrounded by streets and more swales, but the streets will also act as streams to collect the water on its edges. Here's another shape. These are spherical when they are single bubbles, but when they are hexagonal, when they are multiple, they are hexagonal, which is, I mean, it's one of the most beautiful things about chemistry and nature in general. So basically, these are some shapes that we can look at for different, if we want to organize different neighborhoods to make a district, which is also larger in shape. These shapes come from erosion as well. Over here, you can see the different elevations. Elevations are very important for catching water. The sandstone erosion, the spider web, also different elevations, also different districts, just like the historical Arab cities and Islamic cities. The spider web over here. A spider web also reflects UV radiation, so birds can see them. The fungus, also in building homes, the fungus shapes can be mimicked to give them more convection currents in the house. And these shapes can be added at the top of the house, and they can create more soundproofing and more convection, so better ventilation. No crystals. There you go. The honeycomb, everyone's favorite. The reason why we have this honeycomb shape is because bees, they have the honey in their mouth. So when they spit the honey, the best shape to maximize space efficiently is the hexagonal, because the honey falls into it directly and it doesn't like get wasted. So there's no waste in such shapes. This is our queen bee. The bioluminescent. All of these shapes. From the microorganisms. And that they give out they give out a color. They call it geomimicry. Not biomimicry, geomimicry. So level 1 is mostly what we look at for shapes and forms if you want to look at your design of the streets. So you can use these shapes that I showed you, or you can go to asknature.org, as I will show you now, and you can look up whatever you want, whichever biological strategy you're looking for. Are you looking for storing, distributing? Distributing is also a good one here for you. Maintaining community, making, moving. Moving is good for transportation. Processing information as well. So you can see here many examples that you can click on, and you can mimic their shape and form, and then use that. So here, for example, here's the honeycomb. Again, here's the leaf. I clicked on get, store, capture, and distribute resources, and I got all of these examples. So feel free to enjoy and look at these and the shapes of the leaves. So